Today our presentation topic is LCR measurement. Contents: Introduction, LCR meter basics, bridge method, LCR bridge measurement guidelines, applications of LCR measurement, introduction. An LCR meter can be used to determine impedance, the complex resistance created by alternating currents. This instrument, the impedance, was measured internally and converted for display to the corresponding capacitance or inductance value. Readings should be reasonably accurate if the capacitor or inductor device under test does not have a significant resistive component of impedance. LCR meters or LCR bridges are the items of test equipment or test instrumentation used to measure the inductance, capacitance and resistance of component. LCR meter basics: the two main techniques are used to form the basis of an LCR meter. Bridge method, current voltage measurement. Bridge method: this method uses the familiar Wheatstone bridge concept as the basis of its operation. The aim of this condition where the bridge is balanced and no current flows through the meter. At the balance point, the bridge component positions can be used to determine the value of the component under test. This method is typically used for lower frequency measurements, often measurement frequencies of up to 100 kHz or so are used. Bridge method working. In bridge method, the device under test, DUT, is placed in a bridge circuit as shown, and its value can be determined from the settings for the other elements in the bridge. It is the LCR meters using this technique that are known as LCR bridges. The DUT impedance is represented by ZU in the circuit. The impedance Z2 and Z3 are known. The oscillator circuit generally operates at frequencies up to about 100 kHz and can usually be selected before the test. Then Z1 can be changed until no current flows through D. This is the balance position for the bridge. At this point, the four impedances in the circuit. This basic bridge circuit is sometimes used on its own in very primitive LCR meters. Some very old instruments actually have the elements that are manually balanced. However, technology has moved on and higher levels of integration coupled with operational amplifier circuitry enable accurate automated versions of the circuit to be used. Current voltage measurement: the current voltage approach is normally used for components that are to be used for higher frequency applications. It provides a highly accurate measurement technique that can be used at high frequencies and over a wide range of values. Two types of the voltmeter and current meter arrangements. For low impedance measurement, for high impedance measurements. For low impedance measurement, in low impedance high accuracy mode, the instrument's output resistance is reduced, and the measurement current is applied repeatedly for increased measurement precision. When measuring a capacitor with a high capacitance of greater than 100 microfarads, and therefore low impedance high precision mode yields more stable measurement. For high impedance measurements, using the voltage and current values from the measurements, the impedance of the device under test can easily be derived. By using a phase-sensitive detector to make these measurements, the relative phase of the voltage and current can be used to determine the impedance of the device under test in terms of resistance, capacitance. Our bridge measurement guidelines: effective lead length. At frequencies above 1 MHz or so, the lead length can start to have an effect. As a rough guide, a good estimate for lead inductance is around 10 nanohenries per centimeter of lead. For the best measurements, keep the leads as short as possible. Measure at operational frequency. When making measurements using an LCR meter, it helps to use a test frequency as close to the actual operational frequency as possible. Adjust test amplitude. In the same way that it is good practice to measure at a frequency that is as close to the operational frequency as possible, the same is true for the test amplitude. This is because component values may vary with the signal applied. This is particularly true for inductors that use cores such as ferrite that may introduce losses. These may be amplitude dependent. Discharge capacitors before any tests. Applications of LCR measurement. LCR circuit has applications in radio and communication engineering. They can be used to select a certain narrow range of frequencies from the total spectrum of ambient radio waves.